Hello and welcome to the Forrester High School Maths Department's Level 3 Support Materials. My name is Mr. McDonald and today I'm going to be talking you through your topics. Our topics for today follow on from what we learned last week about scale factor. Today we're going to be looking at identifying the scale factor that is used on a pair of shapes, and also we're going to be looking at finding missing sides of scale enlargements or scale reductions. So to start us off, I just want to remind you what we did last week. And we learned what a scale factor was. A scale factor is a multiplier that can be applied to a shape's sides in order to make it bigger or smaller. Okay, so that means that we're taking a number and the length of the shape's sides, and we're multiplying by that number to make it so many times bigger or so many times smaller. The angles of the original shape don't change and its general appearance won't change. It'll still look like that original shape. It's just got much bigger or much smaller, or a little bit bigger or a little bit smaller. Okay, so here we have an example of a scale factor enlargement. Okay, the enlargement means the shape is getting bigger. So here's our original shape here. I'm going to put an O in there for original. Okay, and here's our new shape up here. I'm going to put an N in here for new. Okay, and to find the scale factor that's being applied to these two shapes, I'm going to take a side from my old shape and a side from my new shape and see how much bigger the new shape is than the old shape. All right, the way that we do that is as follows. All right, I'm going to write SFE. That means scale factor enlargement. Then I'm going to take a side from my new shape, okay? So I've got two sides on my new shape. I've got 9 centimeters at the top, and I've got 7.5 centimeters on the right-hand side here. I'm going to take the 9 centimeter side to make it a little bit easier for myself. And then I'm going to divide that by the corresponding side on the original shape. Okay, so as you can see, I've color-coded these. 9 centimeters at the top here matches with 6 centimeters at the top here. And 7.5 centimeters on the right-hand side matches with 5 centimeters on the right-hand side. Okay, so like I was saying, my scale factor enlargement is found by taking a side on the new shape and dividing it by the corresponding side of the old shape. So I'm going to divide this by 9. Sorry, I'm going to divide this 9 by 6. Right, if I want to work in fractions, I can simplify this down. I get a fraction of 3 over 2. And I get that by just looking at these two numbers and deciding what times table are they both in. Well, they're both in the 3 times table, so I'm going to divide this by 3. And I'm also going to divide this number by 3. And that gives me a simpler equivalent fraction at the bottom here. So that's my scale factor enlargement there. I'm multiplying by 3 over 2. If you're not happy with fractions, we can turn it into a decimal. How many times does 2 divide into 3? Well, that's a bit tricky to know off the top of your head. But if you are good at your division that we've been practicing in our numeracy lessons, then you can divide 2 into 3. 2 goes into 3 one time with a remainder of 1. And then 2 goes into 10 5 times. So we could just as easily say that our scale factor enlargement, SFE for scale factor enlargement, is equal to 1.5. And that is how to find a scale factor from two shapes that have been enlarged or reduced in scale. Okay, so here's the second example, and this time it's a scale factor reduction. Okay, I'm starting with a shape on the right-hand side this time. So this is my original shape. Okay, and it's being transformed to be smaller. So this is my new shape over here on the left-hand side. Okay, so just like before, I'm going to put down my 3 letters. This time, instead of SFE for scale factor enlargement, I'm going to say SFR for scale factor reduction. You guessed it. Okay, and I'm going to take a side from my new shape that has a corresponding side on my older shape, my original shape. Okay, I'm going to use 6 this time. So the green side 6 here on the right hand side, its equivalent side, I can't use 15 because it's on the top, it corresponds with 3. I have to use 30, which is on this right hand side, just in the same position as my original 6 was. So I'm dividing 6 by 30. Again, if I want to simplify that down, I need to think about my times tables. What times table is 6 and 30 both in? It's in the 2 times table, it's in the 3 times table, but the biggest one is they are both in the 6 times table. So I'm going to divide by 6 to make an equivalent fraction that is simpler. Okay, fully simplified, this is 1 over 5. Oops, that's not a very good 5. Let's try and rub that out. Much better. Okay, I can also put that into a decimal form if I want. Some of you might know the equivalent of 1/5 as a decimal, but if you don't, it's nothing to panic about. Let's just divide the number 1. I'm going to put a decimal place because I know 1 doesn't divide by 5 without leaving some remainders. So I'm going to go into decimals here. I'm going to divide that by 5. Okay, so 1 divides by 5. There's no 5's in 1 with a remainder of 1. And 5 into 10 goes 2 times. So I could also say that my scale factor reduction is equal to 0.2. Either one would be totally acceptable. Fractions or decimals, whatever you prefer to work with. Okay, so the process that you go through to find a scale factor enlargement or a scale factor reduction is take a side from your transformed shape and divide it by a side that corresponds from your original shape. At this point, if you want to take a wee break from this video and my voice, I honestly don't blame you if you do, you can do the first exercise from the support materials that you've got in your assignment for this week's Show My Homework. And then you can come back and do the second part of this video, or if you want to watch it on to the end, then feel free, and then you can complete all the assignment materials as a oneer. Right, so I want to take this idea a step further now. Okay, in our first example, we found that this orange shape had a scale factor enlargement of 1.5, meaning that everything on the left-hand side shape, if you multiplied those by 1.5, you would get what was on the right-hand side shape. Okay, I've taken this a step further by adding in a couple of unknown sides now. I've got side x down the bottom here, and I've got side y over on the left-hand side here. Okay, and what I want to do is I want to find out how long are those two sides based on the information I have in my original shape. Okay, so just to remind you, this bottom shape here is my original shape, and this top shape here, that's my new shape. The direction of the arrow tells you that. Okay, so I'm going to take what I know about this old shape, my original shape, and I'm going to figure out what I can figure out about this new shape that is unknown to me at the moment. Okay, so I'm going to start by calculating x centimeters. We know that x is equal to the scale factor enlargement multiplied by whatever the corresponding side of x is. So you can see it's got a nice blue highlighter on it here. So looking down at this shape, the blue highlighter from this shape is 4 centimeters. So I'm going to take that 4 centimeters that corresponds with my x centimeters, and I'm going to multiply it by that scale factor enlargement that I know has been multiplied throughout the original shape to make the new shape. 4 times by 1.5 is equal to 6 centimeters. So I know that that side length that is marked with x centimeters is actually 6 centimeters. Okay, and that's my final answer. I've got a length for that. If I want to try y, which is up here on the left-hand side, I do exactly the same thing. I write down y. I write down the corresponding side of y, so y is in pink. You can see that 2 centimeters over on the original shape is pink, so we're going to do 2 centimeters times by my scale factor enlargement, and that is going to be equal to 3 centimeters. And again, that's all you have to do. Nice and easy. If you're not sure about multiplying by decimal numbers, then by all means use a calculator if you have to, or set up some chimney sums, which would be even better and help practice your numeracy skills. I've also added a bit of additional information into the second example that we looked at. This is the scale factor reduction. Okay, so in this case, my original shape is up on the right hand side, and we're traveling through scale factor to our new shape here down at the left hand side. Okay, we figured out in the previous example that my scale factor reduction was 0.2. So all I need to do to find W centimeters, which is a variable here, I don't know how big this is yet, is write down W for a start, just to show what side I'm looking at. Okay, we're going to write down its corresponding side length. So that's the blue here is 20, which matches with the blue of W. So we're going to write 20. We're going to multiply that by the scale factor reduction. So 20 times by 0.2. That is going to be equal to 4 centimeters. Okay, and again, it's as simple as that. Once you've got a side length in centimeters that's not a multiplication, then you've got your final answer. One last minute message from me before you complete your task. Remember that you can watch this video again and again and pause if you need to take notes. You can always ask for advice from your teacher or myself through Show My Homework. And the deadline for this activity is, remember, Friday the 1st of May. Best of luck to all of you, and keep working hard. Well done.